it might be it might be wise to start with both of your backgrounds before we jump into OpenAI and talk about OpenAI's history, its founding, and sort of its core mission. And then we'll also later talk about its current research and the work you're doing in robotics, video games, as it turns out, and natural language processing.
Yep, for sure. Can everyone hear me? Raise your hand if you can't hear me. So my background is, I got into my first exposure to AI was actually reading Alan Turing's 1950 paper called Computing Machinery and Intelligence, which is the paper where he lays out the Turing test. And actually, the thing that really excited me about this paper wasn't this amazing idea of that you could actually have a machine that could learn and that could perform tasks at the same level as a human, but was actually this piece in there about how we're going to build such a machine. And the thing that Turing said is that we're never going to be able to program something so complex. So instead, we're going to have to learn. We're going to have to build a machine that we can show it data, show it the world, just like you would a human child. And then it's going to be able to learn to accomplish these tasks so well. And that idea, I think, really infected me. And the only sad thing was this was 2008, and none of this technology actually existed. Nothing worked. And so I really spent, a bunch of time doing a bunch of startups, and I was at Harvard briefly, MIT briefly, before coming out to Silicon Valley, but was always kind of waiting for the time when it felt like this technology actually existed. Ilya is someone who actually really started to bring this to the forefront in 2012.
Yeah, so in my case, I somehow, as a teenager...
I think your mic...
Oh,
yeah.
Mic's not working? It's working? Okay,
Apologies.
An old-fashioned mic. Yeah, so I got into AI pretty early. I was very interested in math and brains and what am I? And I'm a computer. How can that be? That's very strange. So AI was very interesting, and within that, machine learning specifically was the really mysterious thing, because in math you got the logic, the deduction, but how can you know that the sun's going to rise tomorrow? What's the basis for that? So anyway, I concluded that machine learning is the single most interesting thing, and so I went to grad school. I was in Toronto. Fortunately, Jeff Hinton was in Toronto too, and we started working together, and I was working with him for 9 years until we made our big advancement in 2012.
Yeah, and so you both co-founded OpenAI, and OpenAI has attracted pretty impressive backers like Reid Hoffman, for example, and Peter Thiel and others. So can you talk about sort of why you founded it then? I mean, what is driving you forward? What is the thing that you point to when somebody asks, why are you researching this?
For sure. It's a great question.
Yeah, so I'll go first. I mean, for me, there were multiple motivations. Oops.
Some kind of Amber Alert or apologies.
Oh, wow. Yeah, so I had multiple motivations. I was working at Google. I was very happy there, but I felt that I had multiple feelings. I felt that AI is going to be extremely impactful. I thought that AI, the notion of AI safety is important, and I thought that a new organization like OpenAI would have a chance to do a truly dramatic advance. And most importantly, I met Greg, and I thought that this would work.
Right. And
yeah.
Greg, I thought I'd also like to hear the answer to the question from you, and then also maybe you can touch on why you decided to found OpenAI as a nonprofit and sort of its recent transition to a cap profit, which is an unusual structure. Two questions in one there.
So in 2015, almost I guess 4 years ago to the day, we had a dinner in Palo Alto, and 4 people from that dinner ended up co-founding this company together. So that was the 2 of us, Sam Altman and Elon Musk. And the thing that I think kind of brought us all together was a shared vision for where AI technology was going. Right? In 2012, Ilya and his collaborators had really kicked off the deep learning wave. And all of the AI progress that we've seen since then, which has been really amazing, really comes from this one piece of technology that had really come on the scene with that work. And the question of where does it go, is kind of, it's limited by our imagination only, right? And you think about what could happen if we could really build systems that are able to work with people on solving the most complicated multidisciplinary challenges that humanity has to face today. For example, climate change. For example, giving everyone low-cost, affordable health care. You could imagine that the impact of this technology would be like just completely unlike anything we've seen before. And so I guess that we all saw the upside, but there's also the flip side. If anything is going to be really powerful, is that you have to ask, well, what are the risks? How can this go wrong? How can we make sure that we're applying the right ethics and that we are building this technology in the right way? And so I think that this dual concern is what caused us to come together and form an organization. And that the main motivation for us is to try to build this technology, which we call artificial general intelligence, and to make sure that it benefits the world, and that's what all the choices that we make as an organization end up funneling into. And so if you look at the history of the organization, we started as a nonprofit because we didn't really know what the best structure was to actually get the resources, get the people, and to really make the technological progress required to achieve the mission. And then we basically spent the next 3 years working on pushing forward the technology. We had a number of really exciting advances, but also trying to answer the question of how can we really get to not just the current level of technology, but really to build the first artificial general intelligence. And I think that the core of that ends up being computational power, right? That if you look at all the advances over the past 7 years, that they've been all fueled at their core by this massive increase in the amount of computation that they use. And actually, I think we have a slide that shows the amount of compute over time. If we can put that slide up. Should be the slide. Yep. So this is a logarithmic plot. So it looks very linear, but that actually means it's exponential. And so the amount of compute that's been going into these models has increased by about a factor of 10 each year since 2012. And that's a crazy thing, right? Like I think humans are really bad at internalizing exponentials. It's hard to really feel it. So one way of thinking about this, it's a little bit just like if your cell phone battery, which today lasts for a day, 5 years later started to last for about 800 years. And then you went to sleep and you woke up 5 years later, and now it's lasting for like 100 million years, right? That's the kind of increase that we're really talking about for the amount of brain power going into these systems.
If only. Yeah, my smartphone battery lasts about a day, if I'm lucky.
That's right. That's right.
Right.
Yep.
It's a great analogy. But yeah, so maybe you can talk about how, what that's enabling. Some of the current work that you're doing, as I mentioned, in video games, Dota 2, a popular MOBA, as they call it. It's a online strategy game. And sort of, sorry,
Yep.
One little addendum to that. Maybe talk about the broader applicability of that sort of work. It's not necessarily, video games that you're trying to, master. It builds toward this artificial general intelligence you mentioned a second ago.
Yeah, so one way to think about our work on video games is that it combined reinforcement learning with compute. So reinforcement learning, when it came on the deep learning stage in 2013 with the DeepMind Atari work, it was exciting, but the games also looked simple. And it didn't really seem like reinforcement learning could do much. And so the way I like to think about our work with Dota is that we've shown that if you simply use a lot of scale with simple reinforcement learning, you can go a lot further than anyone at the time has thought. So now anyone will say, oh yeah, of course you can solve games, of course you can solve real-time strategy games. I mean, that's old news. But that's the way we just get accustomed to technology, in the same way that we get accustomed to a new version of iOS 2 weeks after it's installed on our phones. But yeah.
And just to add to that, so the thing that I think is really important to understand is how this technology really works. And so if we go to the next slide, that what the AI sees is just a big list of numbers. As far as the human's concerned, there's a game with a bunch of characters running around. That this game is played professionally by a large number of people that live together in these gaming houses, are very, very intense about this game. As far as the AI is concerned, it's just a big list of numbers. And if you go to the next slide, you'll see that for other work we've done, the AI sees the exact same thing. It's just another list of numbers. And so, another work that we did last year was that we managed to have a controller for a robotic hand, which is something that no one had done before. People have spent 20 years trying to figure out how to program these robotic hands to perform any sort of meaningful task. And it's just too hard for human programmers. But using the exact same technology, using a system that just sees a big list of numbers and gets a reward whenever it tries things, we were able to both beat the world champions at a video game and also control this robot hand that no one had been able to do. And so this is the real core. This is the kind of technology that really sparks the imagination, that you think about what other problems can you turn into a list of numbers that are meaningful to a computer, and then allow it to figure out the strategy that is required to maximize reward. And the answer there is pretty limitless.
Yeah, another one of those problems that you seem to be on the way to solving is natural language, basically generating very convincing snippets of Amazon product reviews, could have been read by a human, some of them, or just, basically a small, short novella. I mean, page-long short story. So can you talk about like GPT-2, this recent, natural language model that you released, and sort of like how it's similar and different from these other projects that you have ongoing?
Yeah, I can start. So what we did with GPT-2 was to take a large corpus of language and then take a very large neural network and then ask the neural network to learn to predict the next character. And we used a lot of GPUs, and that's all we did. And it turns out that, so this is not a new thing. People have been training this kind of neural nets for a long time, but we made it bigger and we trained it on a more interesting data set. And those two things led to what appeared to be a disproportionate advance in natural language processing and natural language generation.
And I think that an interesting core here is that we basically had been pushing on the same kind of paradigm for about 2.5 years. And the first successes that we saw were with this paper called the sentiment neuron paper, where we trained a neural net to play this exact same game. So you're given some text, you're asked to predict what comes next. What would the human write next? And that we saw that when we had a model of a certain size, that the model actually learned a state-of-the-art sentiment analysis classifier inside of it. And this was a surprising thing, because we've been asking this model to just predict what comes next. And so the obvious things it's going to learn is going to learn the spelling of words, it's going to learn where you put a space, it's going to learn where you put a period, it's going to learn these very detailed statistics. But this was the first time that anyone had seen semantics emerge. We hadn't told it anything about what these words meant, but somehow it found something that was meaningful. And here's the other crazy thing, is when we shrank the model by a factor of 4, this effect totally went away. And so GPT-2 is just the scale up. It's a slightly different architecture, there's different tricks in it, but fundamentally, it's a neural network that we scaled up. And suddenly, we start to see all sorts of really interesting behavior that it can actually write these essays that are actually pretty convincing. It wrote this essay about why recycling is bad for the world. And you read it, and it's actually making this argument about, well, the problem is that we're actually generating all this waste in the first place. And so really, we should go and we should be looking at the supply chain. And it's actually pretty convincing. Someone posted this on the recycling bin at OpenAI, entirely written by a neural net. And when we read that essay, we were like, this has to be copied from somewhere on the internet, because that's how the model was trained. And we spent a long time really trying to find some forum posting where someone would say this kind of thing, and we couldn't find it. And so somehow the neural net, and maybe it's rephrasing things that other people said in ways that are more sophisticated than we were able to detect, but fundamentally was able to combine ideas and to come up with something that's actually quite convincing to us.
Right, and that is sort of like a natural segue into the explainability piece of your work. So it's great to have like this really capable model that can generate any sort of text you might want, or understand any text you feed it. But how does it work, right? That's something a lot of people would want to know. And that you're not only doing explainability work in natural language processing, you're also you've made significant advances in explainability with respect to computer vision. So maybe you can talk about like activation atlases, this recent project you detailed in a blog post about your approach to model training that allows people to see, which parts of the neural network are inferring things about the data set on which the network was trained.
Yeah, so explainability in neural networks is an extremely important question because as neural networks get smarter, we want them to do more things, and sometimes they'll make decisions or predictions, and it would be preferable to understand why they made a particular prediction. And these neural nets are being so large, then it seems that it could be challenging to understand what they meant. And so with our work on explainability in vision models, we've done work where we've been able to understand the essence of a single neuron. What is it that a single neuron is looking for? And we've been able to extract those compact, concise circuit diagrams that explain how the recognition of an image is assembled in a human understandable form. And what I would expect to see longer term as this work advances is that we'll apply similar tools to language models and models in other domains as well. And ultimately, when we have a model that's we will use the model's language abilities to explain to us why it made a decision. Mm-hmm. And that will be very useful because then it will tell us, I made decision X for reason Y. So now you know.
And I think this is very exciting because there's really this myth that neural nets are a black box. They give us some answer, totally understandable where it came from. Which, if you think about how humans work, this isn't actually that much better than we are, right? You can ask someone why they made some decision, but when you actually do the psychology research, you'll often find that they made the decision for some totally unrelated reason. But I think we can do better with neural nets, and we're really seeing the evidence that we can. And so, again, really the hope is that as we start to have AI be more, entrusted with important tasks in society, that we can understand why is it making the decisions that it is, that we can ensure that it's actually going to do what we think it's going to do, and that we can then ensure that it's actually going to be used to benefit people. And so I think this kind of work is really important. But there's actually a second reason that I think that this work is really important, which is actually a collaboration with Google. And I think that one of the things that's really important as you bring transformative technology on the scene is that you have cooperation on these axes of ensuring that it's safe. Right? It's good for everyone if car manufacturers coordinate on seatbelts. And I think it's kind of good for everyone if everyone developing AI coordinates on safety.
Absolutely. So I think it's maybe important to mention, and you have detailed it in blog posts previously, but that when you released your GPT-2 work, you decided not to publish the model that is most capable that we've been talking about, the model that can generate this convincingly human-like text. And you said you were worried about how it might be abused. So do you think once the explainability piece is there, and you're working with these models that can basically tell anyone who's using them why they made the decision they made, you'll no longer have to be as concerned about that as you are now?
Yeah, so I think the GPT-2 release is a really interesting case study. Because from just kind of where it really started from is that we created a model with capabilities that really surprised us, and that it was hard for us to assess what's this going to be used for, where are the limits of it, and we kind of looked at it. We had an internal process where a bunch of people in the company were involved. And the conclusion from this was there's a bunch of arguments for why it's totally fine, and it's just kind of the incremental progress from what people have been doing. There were other arguments for, well, you could imagine this being used to write fake news, and we didn't really try to go and write the best fake news with it to make sure that in fact you could write awesome fake news, but it really felt within the sphere of possibility. But I think that the argument that really tipped it for us was that it's kind of a question for GPT-2. You can make reasonable arguments in both directions. But what is so clear is that as this technology progresses, because remember, this was just a scale-up of previous technology, we're going to have models where it's super clear that they have dual use implications. They can have amazing applications and do great things, but only if they're used in the right way, and that they also could then be used for things that aren't so good. And that as a community, I think that what's clearly missing is an answer for what you do when you have a model of such form. And you really don't want to be figuring this out when you have the super scary thing. right? You really need to have a dry run. You need to have some test run where if you mess it up, if you accidentally leak the model, if someone gets angry and tries to reproduce it, that it won't have catastrophic effects. And so it was really important to us that we raised a flag for, hey, we have to develop a norm for how you cannot share. And actually, I think we're extremely happy with the results, right? We've seen, there was a bunch of controversy, which, I think is unfortunate, and we would have preferred not to have that. But I think it was really necessary for the first time that someone said, hey, we have something we're not sure about, to have that kind of reaction, to let people really, let their emotions out. And I think that we learned a lot from it. And what we've seen since then is we've seen several different groups either try to replicate it or replicate it, and also come to a similar conclusion of, let's hold this back for now. We're working with partners now in order to really study the capabilities and figure out how can you actually use this for fake news mitigation. And I think that these kinds of efforts are really important. And I hope that they're going to set really good precedent for what happens the next time someone has a model like this.
Yeah, and just to add to that, it really boils down to machine learning is becoming more capable. And that's it. The more capable it is, the more are the good ways, but also the bad ways in which it can be used. And so it just gets less clear.
Right. So you said there have been a lot of learnings from this release. Do you think, it's difficult to project, but do you think you might approach, once you develop a model like this, which presumably will happen eventually in the future, another highly capable model, maybe a computer vision model, or a model in some other subfield of AI, you will consider holding it back until you can develop safeguards around it?
Well, I think it's not really about us. In some ways, it's really about community norms. And if you look at the security community, it took them a long time to figure out responsible disclosure, right? So responsible disclosure, for those who aren't familiar, is the idea that if you have a vulnerability that you've come up with on some vendor software, it gives you a path where you first talk to the vendor, and then if the vendor is not being responsive or doesn't handle it in the right way, you can then go public with the vulnerability. And that the community will look at you and say, you did the right thing. And this is a totally non-obvious process, right? Because you release this vulnerability into the wild where people could actually use it to attack that vendor and do who knows what with it. And it really, I think, took a lot of pain and suffering. And I think that there were various people who were sued and attacked for various things along the way to get there. And I think the security world is much better off. And I think we are all more secure because people went through that process. And so I think that I really view what we did as a first step towards helping form community norms. And my hope is that they're now starting to fall into place. And so I hope that, in fact, people will have a better answer for what they do. And I think that we've already developed a few extra norms that I think are helpful, like delayed release or engaging specific partners, and then you can go out together. And I think that those things actually mean that it should just be a less big deal in the future when people have models that are kind of, they're uncertain as to their implications.
Mm-hmm. Yeah, so I want to end on a slightly more upbeat note. You both have talked about really interesting developments coming down the pipeline, the current work that you're doing. But what really excites you each personally in the field of AI? Whether it's like the research within OpenAI or just speaking more broadly about papers you've seen published on Archive. I would just love to hear your thoughts.
Yeah. So the thing I find most exciting is that deep learning has a lot more potential to go. That if we train larger neural networks, they'll do more. And I hope that we'll get them to solve tasks we can't solve right now. For example, I hope we'll be able to make some progress in reasoning as well. That would be quite nice. Yeah, so just train larger networks on harder problems. That's what I'm excited about.
So the thing that I'm excited about is something Ilya touched on in various ways right there, which is a new team that Ilya and I are leading at OpenAI called the reasoning team. And the problem that we want to solve is kind of, to some extent, this question that's been around from the day one, which was, is it better to go the symbolic systems route or better to go the neural net route? I think the answer is you need both. And I think that we're really excited to actually get neural nets that are capable of reasoning and solving tasks they can't today.
Yeah, outstanding. Well, I look forward to reading about it soon, I'm sure. Well, thank you both.
All right, thank you.